Hey everyone, welcome to episode 5 of season 3. Trying to keep track of this stuff. It gets hard when it all blends together, but I'd meant to come on earlier today, but things got weird when I was working with the code and I couldn't get it to work right. I had to sort some issues out, and so I had to delay, but we're up and running now, so it should be good to go. Um, we left things off last time where the consumer was working, we were creating the burgers, we were running everything through the routing slip. And after the call, after that session, I was going to do I did some cleanup and I wanted to kind of go through that before I jumped into the content for today. Hey, Albert, how you doing? Um, so let me go into that first. When we previously had the order controller, the submit order consumer, it was doing all the routing slip creation in it, and in systems that I've built before that have used routing slip, we tend to use, we gave them different names throughout history, but I use the term itinerary planner for this, because I wanted to decouple the actual building of the activities from the consumer. And so what I've done is I created an itinerary planner for the burger type because we want to cook a burger. And in the itinerary planner, that's where I'm actually using the activity details and actually adding the activities and the arguments to the routing slip. So it just kind of gives us a little decoupling there so we can take care of that. And as we bring new types in, as we enrich the menu with additional food items, we'll create additional planners for those types of itineraries. So you can see the weight, the cheese, everything in there is still added on. Dang it. Wish we could turn that off. It's awesome. So anyway, the itinerary planner there is, yeah, that kind of threw me. So we're gonna build the itinerary from the consumer now. Instead of doing the activity adding within the consumer, we've teased that out. It still works the same way that it did before. We have the routing slip request consumer and the routing slip response consumer. And all of that is still in place. The itinerary planner just added a couple of interfaces. I also went back to the model and I wish I could turn that off. Hold on just one second. Let me just adjust that. Okay, so I've adjusted the order model a little bit to where I'm actually passing in the burger. And the burger model has all of the details in it now. So this is going to be to where we're going to kind of extend the menu a little bit. And so all the details for within a burger are part of this burger record, including the weight, lettuce, and all that kind of stuff. And the order that's initially submitted includes that. So if I run this, and I got tired of using Swagger, so I installed Postman and created a Postman thing for it. This way I create the order, I got the burger in there already, and I can just hit send to test it. I can see that it's running over in the other window. It's grilling up the burger. It's creating everything, getting the returns, and then I get the burger back in the window. So everything works great. It works the same. It's just now I have an easier test rig that I don't have to cut and paste all the time. So good. So that's all working. That was just the cleanup I did there, and that's checked into the current repo. What I wanted to go over today, and this was kind of the point of that I ran into with the problem, is when we currently the way we're creating the routing slip and completing it, we aren't necessarily really keeping track of it. I mean, we're putting the state within the routing slip so that we don't have to have a database to keep track of that request, and then we're responding to that request with the consumer. The challenge with that is that future, that conclusion of that routing slip is, it's ephemeral. There's no other place beyond that routing slip where it is, which is fine, except that as we scale this system up, we're going to want to keep track of all the different things that we're cooking. And we also want to support idempotency so that if we get the same order twice, we aren't going to go and cook 2 burgers and have extra ones. And that's just one example use case. I mean, you don't want to be spanning orders out and dual shipping orders. what I'm planning to do is I want to be able to keep track of all the different things I order, and I'm going to need a tool to do that. And so I'm going to check out my other branch here, and hopefully Ryder will catch up and everything will be great. And so what I've done is I've gone away from using the routing slip request response consumer. I'm still creating the routing slip and everything because I moved that out to the itinerary planner. So the itinerary planner is still there. The logic for building the routing slip is still there. But the submit order consumer has been changed a little bit. And it's changed because I wanted to stick with the request response metaphor. I wanted us to stay where we were sending a request, and then when the request ID completes or whatever, we will take the next step. Because I think what we're going to see is that's going to be something that we're going to build upon. And I want to build upon that as long as we can, because it's really that multi-type future that we have. So when you think about the .NET runtime and you have task of T, there's another class within the .NET runtime called task completion source. And what task completion source does is it allows you to either set a result, set an exception, or cancel the task that is part of that task completion source. And I want that same type of capability within my distributed message system, because a task it's tied to the process, and it's how the request client works. The request client creates a task completion source for all of the different response types that are supported. And as responses come in, it will complete those tasks, that task completion source, by setting the result on it, which then completes the task that I'm awaiting on here with get response. So I want that same type of construct, but I want that for the routing slip. I want it to be able to work across process boundaries is basically where we're going, even though we're all in one process here. And to do that, I have to have some identifier for it. So obviously we're going to use a GUID to keep track of that. And we have to have some sort of state for that. And so what I've done is now the submit order consumer, I've changed it to have a request client of its own. And we're going to see that this is going to fan out even more once we start to fork. But for now, we're still just creating one burger because I want to stick to just a single routing slip at this point. But I've put a request client in here for the request burger message, which the request burger, it includes an order ID and the burger, and that's it. It's like, hey, this is the burger I want to cook, and I need this burger cooked. I don't care how it gets done. I just need it done. The other thing that it's going to do is it's just going to do that, and it's going to look for the two responses, burger completed and burger not completed. And I've tied these to burger because this one is specific to that itinerary planner for burger. And I think what we'll see as we grow this sample and add fries and chicken sandwiches and who knows what else, shakes, you got to have shakes. Ice cream, the ice cream machine is always going to be broken, but we'll still support it on the menu. But we're gonna look at how we're gonna add additional types and how we might see that let's see here in the chat. Chris, the code looks fuzzy. It shouldn't. Check your Twitch resolution. I'm uploading at 6 megabits, so it should be clear. I have no drop frames, so you might just check, make sure your resolution setting in Twitch is 1080p 60. So what I did is I put the request client in here, and this is all the submit order consumer does now. And it's always going to be, it's going to use that same request response pattern. And for now, the consumer will stay alive until it's done, but so is our controller at this point, and we're going to tease that out later. We want to just kind of stay focused on what we want here. So if response is burger completed, we're then going to complete the order, because right now we're just sticking with a single burger for the order. And if the response is burger not completed, then the order's not completed. So we aren't joining things back in because we aren't forking out yet. We're just waiting for that one burger to be done and then doing something with it. If we do get a weird exception, we're doing order not completed, and we're just setting the reason to that because we want to complete that request client without going into an exception. Technically, we probably could just do an exception here, but I'm not at this point. So what is handling this burger request? So let's see here. Request burger. Request burger is used by the burger state machine. So yes, it's time for state machines. And this state machine is handling the request of a burger. Now, season 2 is all about the state machine, so I'm not going to go into a whole lot of details, but I want to explain what's happening with this one. So when you think about a task completion source, it is either waiting for completion, it is completed when they call try set result, it is faulted when they say try set faulted, or it's canceled, which I haven't handled here yet. And so I put those exact same three states in here. I put those exact same three states in here: waiting for completion, completed, and faulted. And I have the initial request that comes in, the request burger, which is burger requested. And hey, Brave Cobra, welcome. I also, because I'm running a routing slip to do this, I have two events that I handle: the routing slip completed and the routing slip faulted. So the burger completed and burger faulted events are in there. Those are correlated by the tracking number, which I'll keep track of in this state machine because it's part of the future. The completion or failure of that routing slip is going to determine the outcome of this state machine. And the burger ID is going to be there. So this is just set up here. And what we want to do is initially when the burger is requested, we're going to write out a log message. We're going to save the order ID and the burger in the saga, so we have a copy of that request. And then we have an activity called prepare burger activity. And all of the code that used to be in the submit order consumer is now going to execute as part of this state machine activity. So you can see we have the itinerary planner for burger. It's the prepare burger activity. We're going to set up our tracking number, create the routing slip builder the same way we did before. We're going to add the subscription back to the state machine, so we just use the input address of the consume context. If the expiration time is there, we set the deadline. We add the order ID and burger ID as variables so that we have them. Correlation ID on the instance is actually the burger ID because we use that to initiate the saga. And we then produce the itinerary through the planner. I should probably rename that to plan itinerary. I had to use the name itinerary producer originally, but that conflicts with topic producers and stuff in Kafka, and I try not to reuse terms when they're completely unrelated, so I just took that out. And so I'm going to have my plan itinerary. Then I'm going to build my routing slip, I'm going to execute it, and I'm going to store that tracking number in the Saga instance so that I have that to correlate to. At that point, that's going to complete. Yeah. So the prepare burger activity runs. Then here's where I ran into a bug in MassTransit this morning, because that's why I had to wait. I had to actually fix the bug and wait for the builds and all that. And this bug's been there forever. I'm surprised nobody's hit it, but I guess nobody really uses that feature. Request started works great. And what this does, and I can show you the code, request started basically announces that we've started a request. So I'm not going to go too deep into the code because I'll just kind of show the flow of this some more. But there is a separate state machine in MassTransit that keeps track of requests. It's called the request state machine. And by adding these extension methods, these activities to your own state machine, you can keep track of incoming requests. And then you can either complete or fail those requests based upon subsequent events in your state machine. And by keeping track of that in a separate state machine called the request state machine, it deletes the instances as soon as they're used, so they go away. But if you have multiple requests come in for the same type, it will queue up those pending requests for the same data that with the same, like the same burger ID. And when the request actually completes, it will complete all of those pending requests. So when you think about a task completion source in the .NET runtime, it does the same thing. You create the task completion source, you return the task out. You have a number of different continuations that other systems async and await on that task and build up on that list. And then when the task completes, it goes off and schedules all those other tasks that were waiting on that task to complete to execute. So this is working the same way. It's basically saying, when the request is completed, we're all going to be there and we're all going to be happy. So while it's waiting for completion, if another burger is requested, all it does is, not this, call request started saying that, hey, I have another request that was started, and it will capture the response address, the fault address, all that stuff that we were putting into the routing slip. It captures that as part of the request and then produces that event over to that other state machine. Meanwhile, while we're waiting for completion, if we do get the burger completed event, we're going to save that burger because we now have the real burger. we are going to call request completed and create the burger completed message, which is down here called burger completed, which we put the order ID in it, but we also just put the burger in it, which is the completed burger. We also then transition to completed. If we do get faulted because the routing slip faulted, we will put a reason in based on the activity exceptions that were in the routing slip. We will complete the request with burger not completed. So this is what wasn't working. It wasn't respecting this type, so the types were skipping. It was only passing the type of the event. So it was just it was literally the wrong generic argument in an initializer. So simple fix, but took me a while to find. So I will either complete or not complete the burger. Now, once I'm in a completed or faulted state, if another request comes in for that same burger, I will just immediately complete it because I've already done it. If the burger has the same ID, I've already completed that burger. So it sort of caches the result too, so that I become idempotent. I'm not going to return multiple, I'm not going to create multiple burgers for the same burger ID. So it gives me some cool features, and it's using that built-in request state machine. So that's the state machine that I put in place to handle the execution of the routing slip. I think what we'll see later is we might actually get in and go in and put some retry and some recovery and some fault handling for this. So, you know, we've set ourselves up to be able to do that now, to like track reties for the state machine. The burger state is pretty simple. I have the order ID, tracking number, the burger, a reason it failed, what the current state is. And then I also created a saga definition for the burger saga, because I want to partition based on those correlation IDs that come in. I don't want to try to, you know, basically just keep things neat, so I'm not trying to do multiple things to the same state machine at the same time. The request saga, I created a definition for because I want to kind of tune the behavior of that. I've said I want 64 partitions. I'm partitioning based off the request ID that comes in or the correlation ID of the saga, so pretty simple. Just to kind of split that up a little bit and limit, you know, so I'm not hitting the same saga with multiple requests. I think I did this just to make sure that the request was the same. I could actually just get rid of that now. When you're troubleshooting, any place you can set breakpoints is great. So yeah, I can get rid of that too. Okay, so the configuration, I had to do some stuff in startup as well to get that working. I had to add the saga state machine for the burger state machine using that type definition. And right now I'm just using the in-memory repository because I want it to be quick. We'll put real Postgres or something behind it later, or maybe we'll do Mongo this time. I mean, I did Postgres before. I also get the request saga state machine in there with the in-memory repository, so that's up and running. I don't think I did anything else too crazy. I think I had these extension methods there before. I think I had already put the custom endpoint name formatter in there for the last episode, so I don't think I need to go over that again. So now I'm going to run this. I'm just going to run it again. Now that I've pulled in the new version, I'll go back to Postman. I don't want Swagger UI. I'm going to actually probably turn off launching of the browser now that I have Postman going. But you can see I have different state machines. And if we go look at RabbitMQ, I have a number of different endpoints now. I have the burger state, which is the state machine. I still have the same execute compensate for grill burger and dress burger. I have the request state, which is where the requests are going to be stored. I have submit order. I'm not using submit order response at this point. The consumer is still registered, but we're not using it because the subscriptions on the routing slip are now going to the saga. So if we jump back over to the code and then we jump back over to Postman, I'm going to execute that exact same burger that I just created. Because it's an in-memory repository, it's going to run it from scratch. But now that we've added that saga there, you will see an interesting change. So it creates my burger. Everything's great. That seems to work. Let's see what happens if I ask for lettuce, which we know is going to cause the burger not to get dressed. Did you miss the activity diagram? Not sure I follow the question. Okay, so I got my error back that says no lettuce available. The activity diagram, I'm not sure what you mean. If you mean this diagram that shows how the activities execute on success or failure, I don't know if that's what you mean, but There is a diagram for that. I put that on the README, but it shows where the different activities run or fail, or success or fail. And that's on the README and the GitHub repo. So yeah, so it worked. We got our postman. We got the no lettuce available. Let's change this back to false and try one more thing. So let's run another one. And we can see that it's going to go off. It's going to grill up the burger. It's going to dress the burger. And it's finished. Now I'm going to take and put the burger ID back up in here instead of generating a new one. I'm going to take the same order ID, although it doesn't matter because I'm not checking it right now, so I won't even bother changing it. Now when I hit send, it immediately responds. And the reason it does that is because that request lands at that burger state machine and it says, hey, you've asked me to make that burger before and I've already made it and it's done and it's ready to go. So I've added some idempotency for, you know, whatever line item you put in there. In this case, it's the burger ID. By generating those at the source, if I resubmit this order, and I should probably clarify, this order submission API is something that our OMS, our order management system, would use to actually prepare the thing. So while they're building the menu, we aren't, you know, there's going to be something that's going to take from the menu, build the order, verify that the order is valid, and then submit it to us as a completed, ready to process order. So we aren't going to just expose this out to the public. This is going to expect some certain things, and one of the required things is going to be that that burger ID is actually there, and we would have that for every one of the food items in our list so that we can track them all the way back to the source without having to generate identifiers and, you know, have them be different every time we called in. So I could ask it again. It's still going to come right back and say, yep, same burger, I've already cooked it, it's waiting for you on the tray. Good times. So if I put that back to GUID and run it, then we're going to actually create a new burger. You can see I'm at the grill. Grill's cooking it up. It's going to get dressed, and then we'll actually have the burger, and it'll come back out. And it has a different unique identifier. So that's the changes that we put in place, and it's given us this, you know, essentially using that GUID, we have an already completed task of, you know, preparing the burger that is done. So anytime we ask to prepare the same burger, it's like always done. So if we need to reevaluate the entire order in our system and see if it's completed, we can actually rerun the entire process from the start like it was a new submission and have it recomplete everything. Because the future is already here. The burger is already done. It's on the tray. We just can rerun that entire same order again and get the exact same outcome. That's a pretty powerful tool if we want to build a larger system that we want to try to compose across all of these different things. So that's kind of a big unlocking tool. And I mean, mentally, it's like, if you don't understand tasks in the task parallel library and task completion source, I can't think of another parallel for it. I mean, other than that, there's a food tray out there and the food is already on it. So when you're looking, you know, if you've ever been to Whataburger, which you got to drop Whataburger and call like this, they're constantly looking at that printout that's on the bag. And they're like looking down the list and checking the bag, looking down the list, checking the bag. I get it to go. We haven't dined in forever. So, but okay, assume it's a tray. Yes, Texas is definitely represented with the Whataburgers. They're always looking at the list. They're like, okay, do I have this? Do I have this? Do I have this? And they just check it multiply because they know that you're going to look at it as soon as you get it. So they're checking to make sure everything's there. And we could do that same thing here. We could just say, okay, run the order again. Is everything completed? Oh, no. We timed out waiting for because there's no fries yet. Okay, well, we'll check back in a minute. You know, we'll look when we get another event that says, hey, your order's been updated. So that just gives us one way that we could basically reprocess the order to see if it completes and kind of stays within that request response construct is the only way I can describe it because it's there. We have the request ID. Interestingly enough, that creates a new request ID each time we do it, but the burger ID is the same. So we're requesting the same burger. It's just the conversation is different. Because again, I'm submitting that from Postman separate times. So a little bit of a mental leap from just saying everything is new every time. It isn't really, I don't really think of it as caching because you wouldn't cache it A cache would be like, hey, I need the current stock quote for MSFT, and coming back and saying, okay, well, I just checked it 0.1 milliseconds ago. I don't think it's changed. That's a different problem versus saying, hey, I'm creating this burger for this order, or I'm picking this item for this order and putting it in a tote or a tray or a box. And I need to know if it's already picked. And that way it's like, okay, well, this still needs to be picked. It would actually go out and create that routing slip. Or in our case, if the burger hadn't been made yet, it would go out and create the routing slip to make the burger. So that's really what I wanted to cover in this one. It's like I said, I did a lot of the heavy lifting offline, and I'm glad I did, because otherwise it wouldn't have ended well. It would have ended with, okay, this just flat out doesn't work. But we got through that, and everything comes back. I will push up the episode 5 source code. It'll be interesting to, if you look at the version history and do the comparison of the changes for the commits to kind of see how we went from one to the other. That's what I did to kind of see how it changed. So I made sure I mentioned everything. Yeah, so that's how we've created a future or a task completion source to complete that task, the task of preparing a burger, and we identify that with a GUID. So I think there might be one more episode where we kind of do some cleanup on this. I'm going to leave some fluff, but at some point we're going to get to the point where we have to have basically an order with multiple burgers. Maybe that's where we'll start first, is say, hey, I want more than one burger in my order. So that might be something we think about, and we kind of raise up the next step and say, okay, well, now I don't want to use the request client in submit order. I want to create some other construct that is a higher level state machine for the order that keeps track of all the items in the tray. And then we get to the point where we can fork out and have multiple concurrent preparations of burgers, fries, drinks, whatever, running in our system that we're then orchestrating and choreographing, or whatever term fits, because I think they all fit different meanings, back into what that's going to be. So I hope this was fun. I definitely see this as a very powerful and enabling thing. It's cool that I was able to get it working, because I was really struggling earlier. And pull it down and play with it. It should just run. See what the difference is. See how the state machine interacts. Walk through it with the debugger, because it's going to set us up for the future episodes where we start forking out and have to merge things back in. So, hey, thanks for joining on a Sunday night. Appreciate the attendance, and we'll catch you on the next episode. Thanks.